Hello everyone. Today I'm going to be introducing Unit 6 Lesson 2 in Data Management with the lesson of box plots and whisker plots as well as quartiles. Now before we go into this lesson, we need to first understand quartiles. Now quartiles divide a set of ordered data into 4 equal partitions where 4 groups with the same number of data values exist in each of these groups. Now this is pretty similar to something you've learned prior, which is the median. Median divides the data into 2 equal partitions, each containing half of the data values. So let's just show you right now here. This is 3 quartiles which divide a data set into 4 partitions. Here we have the least data value, we have the first quartile, we have the median, which is the second quartile, also known as Q2. We have the third quartile, Q3, and we have the greatest data value. Alongside the information that each of these contain 25% of the data or quarter of the data for each of these because it's equal and 4 partitions. Now I'm going to be showing you guys how to find the quartile. The first thing you need to do is arrange the data set in ascending order. This is incredibly important because if you don't, your data is actually not going to work the way it's supposed to. Another thing that's important is you need to find the median of the data, which is also the quartile 2, and you need to draw a line through the median, where the values to the left of the line are the lower half of the data set, and the values to the right of the line are the upper half of the data set. Next, you need to find the median of the lower half, which is your quartile 1, and find the median of the upper half. That will be your quartile 2. So let's start. Let's find the quartiles for every single one of these. The first thing we see here is that we can divide this into 4 equal partitions by dividing it into 2 numbers per each of these groups. So that means 1 here, and 1 here. Now you might notice is that there isn't a clear value between these 2 numbers. That's because we need to actually find an average of them in order to find the quartiles or median. So let's first find the median itself. Median will be equal to the average 4 plus 5 over 2, which would be equal to 4.5. And there's also quartile 1, which is equal to 2 plus 3 divided by 2, which is 2.5. And then we have quartile 3, which will be equal to 6 plus 7 divided by 2. 6 plus 7 divided by 2 is 6.5, and we have all of our numbers here. Now the next thing we need to do is have this case, but this one's a little bit different if you notice. That's because there's a lot more numbers and the data is a little bit different. This means that we can actually have a line through the numbers because this divides it into 2, this also divides it into 2, this also divides it into 2, meaning that we don't actually have to find the averages. There's no calculations required. Here, our median will be 6, our quartile 3 will be equal to 9, and our quartile 1 will be equal to 3. So quartile 1 here, median here, and quartile 3 here. Now as for an important note, quartiles are not actually intervals. They're data points that are pretty much exactly similar to the median. However, quartiles are sometimes spoken as of data ranges, which is not really correct in mathematical sense. So now I'm going to be introducing the interquartile range. Now the interquartile range is the range of the middle half of the data, which in other words means that it's the distance between the first quartile and the third quartile. So here's the formula right here, Q3 minus Q1. And another thing that's pretty important to mention is that IQR is a measure of spread. So the semi-interquartile range is the next thing, and that's half of the IQR. Semi-interquartile range is equal to the IQR divided by 2. So now we're going to be talking about box and whisker plots. Now these are typically done on graph paper and they're based on quartile values. And there's 2 different types. This one, as you see here, is just a normal box and whisker plot with all of our different data points. But then there's a modified box and whisker plot, which contains outliers, which I'll be talking about after. Now, first thing we gotta mention is that here, this is our interquartile range. We have the minimum, which represents the least data value, the max, which represents the greatest data value, and the IQR along with the Q1, Q3, and the median. Now, it's very important to mention that the distance between the max and the quartile 3 can be different than the distance between the min and the quartile 1. And the same thing can be applied with the median and the quartile 3 and the median and the quartile 1. For example, the min could be here and the quartile 1 could be here, while the quartile 3 could be here, and the max could be all the way over here with the whisker extending all the way back there. That's possible. Same thing with the median. The median could be here, where the distance between median and quartile 3 is less than the distance between the quartile 1 and the median. So now that I mentioned this, another important point is the modified box and whisker plot, and this is essentially used when the data contains outliers. Now, outliers for box and whisker plots are identified as points that lie at least 1.5 times the interquartile range, which is the width of the box. This is from either end of the box. So, in other words, the outliers are points that are 1.5 times the IQR above Q3, and points that are at least 1.5 times the IQR that are below Q1, as you see here with each of these values. So here, I'm just going to be going over a word problem. Some students in grade 9 were surveyed to find out how many plates of fries they eat per month in the cafeteria. The following are the results of the survey. Determine the median, first and third quartiles, which are Q1 and Q3, and the IQR alongside the semi-IQR. So here's our data point. This is part 2 of the question, which we're going to do after. But the first thing we need to do is arrange it into ascending order. That means you need to go through each of these data points and see which one's the less, okay? The 0 is the less, so we put it here. Okay, after that, 1 is the least that comes after 0. So we put it here. There's 3 1s, so we put that. And we just arrange them into ascending order. Now, I've already done this to save a little bit of time. But now what we need to do is basically divide it like we've almost done before. Now here we can see that we can divide it into 4 equal partitions, where each of those partitions contains 3 data points, which is, let me just use a different color for this, but it's from here to here, here, and here. Or, well, that's not it. But here are 4 equal partitions, and in this case we can find median. Median will be equal to 4 plus 4 divided by 2, which is equal to 4. Our Q1 is 1 plus 1 divided by 2, which is equal to 1. And our Q3 is 5 plus 10 divided by 2, which is equal to 7.5. Now in this case, we have all of our numbers here. Now we need to find the IQR. And if you do remember, IQR is the difference between the Q3 and the Q1. So 7.5 minus 1, the IQR is 6.5. And then another thing we could find is semi-EQR, which is a little bit unused in math, but it's still good to know. It's essentially 6.5 over 2, which is equal to 3.25. So now that we found everything there, it's asking us to draw a box and whisker plot for the following data. So let's do that. I've already laid out the x-axis here, going from -2 all the way to 22. It's a little bit more than what our data is. So as you see here, our lowest data is 0, so we go 2 below that. And our highest data is 20, so we go 2 above that, just to show the ranges. So our first data point is 0, that is our min. So we're going to graph our min. Next thing we need to graph is the data in our quartile 1, which is simply just 1. So we're going to place that right there. Then our median is equal to 4, so that should be about here. And then our quartile 3 is 7.5, which is, if this is 7, then this will be 7.5, right about here. Now we need to find our max, which is 20, and that's about here. So now let's fill in our lines, our whiskers. That's the part from the Q3 to the max, and the Q1 from the min. And then we also need to fill in the box. And there we go. We've officially done a whisker plot. But now there's also a problem. We need to figure out outliers for the data. Well, to do this, we can actually do something pretty simple, which is what we learned before. Finding the outliers. Q1 minus 1.5 times IQR will be equal to 1 minus 1.5 times 6.5. That is going to get us -8.75. And Q3 plus 1.5 times IQR will be equal to 7.5 plus 1.5 times 6.5, which is equal to 17.25. Now what this means is that any value below this will be an outlier, and any value above this will also be an outlier. So let's see if there's any value doing that. Well, below negative 8.75, there's no values. Our lowest is 0. But above 17.25, there's only one digit, and that's 20, meaning that we draw a dot for 20, and we only draw the box and whisker plot until 15. So let's draw that out real quick. We have our -2, we start off at 0. Then we start with our 1. We move on to our 4, which is our median. And then we go on to our 7.5, which is around here. We then put our last value at 15 because that's where it is before outliers. And then we still have to account for our outlier, which is at 20. From here, that's our modified box and whisker plot. There's no modifications below on the left side, but there is a modification on the right side. And that's the only difference, is that we don't extend our box and whisker plot that far. And that's how you tell what that is pretty much an outlier in almost all scenarios in statistics. Now, for very large data sets, specifically, creating a box and whisker plot is very challenging. So there's online programs that work very well for creating box and whisker plots. For example, there's a website called metachart.com. I'll be drawing a link right here. This is the written link. It's pretty important to know this for any statistics that you're going to do with it later on. It's metachart.com/box and whisker. And that's it. I hope you learned something new, and I hope you can apply this to your new math.